Good morning, everyone. My name is Hemu, and today we are here for our Palo Alto training. And today, this is our first day. So in day one and day two, I am going to cover these 7 topics. Like what is firewalls? I will go through with what is firewall because some of the people they are from the routing background and all right. Then we will discuss the stateful inspection because this was the technique or technology or mechanism which is developed by the engineers in 1994, and after that it has completely changed the inspection behavior of a device or of a firewall. So we'll discuss what is stateful inspection. Then I will go through with the Palo Alto firewall history, then Palo Alto firewall operating system, Palo Alto firewall hardware appliances, and Palo Alto firewall VM series appliances. Then we will discuss SP3, single pass software and parallel processing hardware. And this is the most asked interview question. If you are going for the interview, they will ask what is SP3? What is the architecture of Palo Alto? Can you explain single pass software and parallel processing hardware architecture of Palo Alto, right? So you have to know SP3. Then I will discuss the packet flow, and packet flow is another minimum 2 hours of session. When we will discuss everything on packet flow. Then I will tell you how you can get the initial access of your firewall. Whenever you will receive a new box, how you can basically get the access. What are the default parameters, sublevels, so everything I will cover with regards to this initial access. Okay. Now, let me start with what is firewall. So guys, a firewall is a software and hardware based network security system. Means a device called firewall. It is a hardware box and it may be a software as well, or it may be a virtual box as well. Okay, means your firewall generally a hardware appliance, which is a physical box. It may be a virtual appliance and it may be also software. Like guys, if you were heard the name of couple of antivirus softwares in your laptop, like in Windows, we have a Windows Defender, right? We have a McAfee, Norton, right? Quick Heal. These are the example of software based firewall. Even though, let me also show you one more software based firewall. If you will go into your Windows and if you will type here firewall.cpl, click on advanced settings. You have these inbound rules and outbound rules. Guys, anyone have any idea about these rules? Why we have these rules on your laptop, on your Windows machine? We are having these rules so they will control what type of traffic is allowed from your system, or who can basically send the traffic towards your system, towards this particular Windows machine. And if you will check here on my inbound rule, see, I have blocked all the HTTPS connection, block ping, right? Why I have done that particular, why I have created this rule? What this rule is doing, it is, I have put the name block ping, but I am allowing this particular connection. And just for the testing purpose, guys, what I am doing, let me just log in. I see you can use any terminal for that. Okay, there is no any hard and fast rule. Let me just run one simple command on the firewall just for the example. So I don't have any interfaces on my firewall. So 1 minute. Let me start my Kali Linux actually. So we will test this thing like software based firewall. Okay. So it will build some type of mindset actually. So it is just booting up. And meanwhile, if I'll go here and if I will type ncpa.cpl, it will basically open the network sharing center of my system. And I'm using Ethernet connection. And if I'll go on my Ethernet connection, and if you will check, the IP address of my system is 192.168.1.13, right? This is the IP address of my laptop. Now if I'll go on my Kali Linux machine, it is just coming up here. And guys, I will use this Kali Linux as well for launching couple of attacks during your training, okay? So you will get some idea about that as well. So, if I will just open the terminal here, and if I'll just hit the ping to 192.168.1.13 my laptop, ping is working, right? And if I'll go on my laptop machine, I have this block ping, right? If I'll go here, and if I'll just select here, block the connection, if I click on OK, click on apply, and now what will happen? Ping to my laptop is stopped working, right? If I'll just press Control C, if I again do the ping, see ping is not working. But if I'll go here and if I'll just open this rule again, and if I'll just allow the connection, if I will allow, click on allow connection, it will allow connection from all the machines. Anyone can ping, and you can see ping has start working. So guys, this is the best example of your software firewall. I hope you got the point, right? We have a firewall software based as well. Okay, so this is the just an example. Okay, now we go back. So guys, anyone has basically work on the Linux? In Linux, in Linux we have a IP tables. Like in Windows we have a Windows Defender, right? In Linux we have a IP tables, and we can also use these IP tables, okay, to restrict the communication on Linux machine. So these are the IP tables or your Windows Defender. These are the example of your software based firewall. Yeah, Burak, I will come on the stateful or stateless behavior. Okay, now. So a firewall is a software or hardware based network security systems that controls incoming and outgoing network traffic. Now, what do you mean by the incoming and outgoing traffic? Now let's try to understand what is incoming and what is outgoing. Let's take an example. This is my firewall. Okay, this is my firewall. This area is my LAN area, local area network, and let's say this area is WAN, which is wide area network or internet. Okay, now let's take an example. This interface of firewall is Ethernet 1x1. Let me use some different color here. This interface Ethernet 1x1, and this interface Ethernet 1x2. Now, let's suppose from this PC, I've initiated traffic towards this PC. I have initiated the traffic towards this PC. So it will basically send this traffic through your firewall. Firewall receive this traffic, it will process, it will exit, it will send out this traffic towards this system, right? This was the traffic flow. Now, to understand the incoming and outgoing, guys, incoming traffic means, or let me just give you the idea what outgoing traffic means. The traffic who is leaving your network means this particular traffic, because this is this area till here. This is your area, right? This is your company area. And outside of this area, here we have an internet, right? And over the internet, do you have any type of control? No, we are not having any type of control, right? So whenever your traffic is going out towards the internet is known as outgoing traffic. And whenever this particular, let's take an example, this particular PC, he has replied. Now when this reply is coming, so this particular traffic is coming towards your network, right? This type of traffic is known as incoming traffic. Means outgoing traffic, the traffic who is leaving your organization. Incoming traffic means the traffic which is coming towards your organization. And what firewall will do? It will control the traffic. Now, how it will going to control that traffic? What it uses for controlling the traffic. Now, let's try to understand that part. Okay. So just give me 1 second. I'm just going back here. Let me just open the same PPT on my browser as well here, because I will draw some drawing on this one. Okay, so you will get the whole idea. Yeah. Now guys, let's try to understand. So let's take an example. I have my users here. These are my LAN users. Okay. Then I have here my switch. These LAN users, they have a connectivity via this switch. Let's take an example. This is PC1. This is PC2. This PC have IP address 10.1.1.100, and another PC have IP address 10.1.1.200. Now this switch have a connectivity with the firewall. Let's take an example. This is my Palo Alto Firewall. Then this firewall has a connectivity with the internet service provider, which is ISP. And this interface is Ethernet 1x1, and this interface is Ethernet 1x2. So this interface is a part of my inside zone, and this interface is a part of my outside zone or untrust zone. Okay, I will come on that again. Now over the internet, I have, let's suppose, this particular server. Let's say this server belongs to facebook.com, and this server hosting the service on TCP port 443, and the IP address of this server is 151.100.100, just for example. Okay, now this is the network diagram I am having right now, guys. Now let's try to understand the things here. So if basically, let's suppose now on this PC, I've opened the web browser and I have typed facebook.com. So what this PC will do? This PC initiate the traffic, it will reach to the switch will forward towards the firewall. The firewall do the inspection, it will forward towards the facebook.com, right? Now when this traffic received by the Facebook, now what Facebook will do? It will basically reply. So let's take an example. It has sent the reply come to your internet service provider, it hit to your firewall, then to switch, and from switch to this PC. Now guys, whatever you are seeing with the green color here, this particular green color traffic is denoting the outgoing traffic, the traffic who is leaving your organization boundary, because your organization has a control till this line, right? This is your organization. These are the devices on which you have control, right? Do you have any control on the ISP routers? No, we don't have, right? They will not give you the access of their routers. We don't have any control over the Facebook, right? So the traffic who is leaving your organization is known as outgoing traffic, and the traffic which is coming towards your organization is known as incoming traffic. So I hope these 2 points are clear. Write yes, no in the chat if this is clear. Incoming and outgoing. Okay, that's great. Now, if you know incoming and outgoing, now there are 2 more terms you have to know. We have to know what is ingress interface. What is egress interface? Now tell me one thing, guys. Let's take an example. Let's suppose from this PC, I've initiated the traffic towards facebook.com. So this PC has forwarded the request like this, heads to the firewall, and it is going to till the Facebook. Now, guys, for this particular traffic, your Ethernet 1x2 interface become the ingress interface. Why this interface become the ingress interface means because whenever traffic coming and whenever it is entering towards your firewall through whatever port or whatever interface, that interface is known as ingress interface. And your firewall is exiting out this traffic because whenever your firewall receive any traffic, it will not hold. It will just process the packet. Either it will allow or either it will deny, right? What it will do, it will basically send out this traffic towards the Facebook via Ethernet 1x interface, and Ethernet 1x1 become the egress interface. So ingress interface is the interface which receives the traffic, and egress interface is the interface which exit out the traffic from your device. So I hope these 2 things is clear. What is ingress and what is egress? This is clear to everyone. Guys, any doubt on that? Just write on the chat if anyone have not understood. I think I got all yes, which is good. Now, as on this particular line, if you will see here, they have mentioned a firewall is a software and hardware based network security systems that controls the incoming and outgoing traffic. Means it controls the incoming and outgoing, right? So let's take an example. Let me draw some more thing here. Let's take an example. We do have one more interface on my Palo Alto firewall, and let me draw with the green color here. This is my Ethernet 1x3, and this interface is a part of DMZ zone, and here I have my servers. These are my internet facing servers. I will tell you what is the DMZ. Let's say take an example. I have my web servers here. Okay. Now these web server, let's suppose having the IP address 10.2.2.100 and 10.2.2.101. This is server 1. This is server 2. Now over the internet, I do have one more user here. This is the internet user. And that user having IP, let's suppose 100.1.1.1. Okay. Now guys, as I have mentioned, like your firewall, basically what it used to do, it will control the incoming and outgoing traffic. Control means either it will allow the traffic or either it will block the traffic or it will deny the traffic, right? Either it will allow, either it will deny. Now, on which behalf basically it will allow or it will deny? Right? On which behalf it will allow, it will deny? Right? Because it's a machine, right? It needs some details. So it will basically allow or it will deny the traffic on the basis of rules or policies or ACLs, access control list, right? Now, what is the exact information it is having into these rules? So your firewall, what it will do? It will allow, it will deny the traffic on the basis of layer 2 information, layer 3 information, layer 4 information, and layer 7 information. What do you mean by the layer 2, layer 3, layer 4, and layer 7? Are you aware about the TCP IP models or OSI model? Or the TCP IP model? Now tell me one thing, guys. Let me just take a very, very basic example who don't know what is OSI model, what is TCP model or TCP IP model. Guys, in every country, let's take an example, has somebody has done some type of like did some type of bad stuff basically. Maybe he basically he has just stolen something from somebody, or maybe he has killed somebody, right? On which behalf basically they basically we judge the peoples, or the officers basically they will judge that particular person on the basis of some type of guidelines, some type of rules and regulations, or some type of law, right? We have articles. So the thing is, this TCP IP or OSI model have the same information. What they have content, they are having the standards or the statements which tells how two computers will communicate, how these two computers can communicate. To allow the communication between two systems, what we have to do, vendor of this computer and vendor of this computer, they have to follow the standards defined in TCP IP model, and they will do the programming according to that. And this TCP IP model, they have a layer 2. At layer 2, we have a source MAC and we have a destination MAC. At layer 3, we have a source IP and we have a destination IP. At layer 4, we have a source port and we have a destination port. At layer 7, we have a raw data. Right? Means what this firewall will do, this firewall is capable of reading the layer 2 information. It can read the layer 3 information, it can read the layer 4 information, it can read the layer 7 information. And what it will do, after reading the information, basically what it will do, it will control the traffic. Either it will deny the traffic or either it will allow the traffic, right? Okay, so we were discussing what firewall used to do. It used to allow, or either it used to deny the traffic, right? Or it used to control the incoming and outgoing traffic. Means incoming traffic, the traffic which is coming towards your organization, and outgoing means traffic going out of your organization, right? And what it will do, firewall used to control. How it will control? Because on the firewall, we used to basically write the security policies. Or if somebody don't know what is security policy, they might know access control list. On the routers or switches, if you want to allow the traffic, or if you want to deny the traffic, what we can write the access control list. And what we have into your security policy and ACLs, access control list or security policies, it is a combination of multiple statements. And what are these statements? What we used to define, we used to define if traffic coming from 10.1.1.100, and if this traffic going towards 150.1.100.100 on port number 443, you can allow or you can deny, right? This is how we used to form the access control list or the security policies. We used to define, right? We used to define in the source field, we will define the source details. In the destination field, we will define the destination details. And we will also define the source port or destination port field, right? Means my firewall, what it will do, it will use the layer 2 information, layer 3 information, and layer 4 information for allowing the traffic or denying the traffic. Means it needed this layer 2, layer 3, and layer 4 information for controlling the traffic. Now I hope you got the point here, how firewall used to basically control the traffic. I hope guys this is clear. I am not putting much here with the layer 7. Let's try to understand first legacy firewalls. How legacy firewall used to do the task, because at layer 7 we have a lots of discussion on what is next generation firewall and what is legacy firewalls. Yes, Bena, you can write your question on the chat. And I hope everyone got the idea here, how my firewall used to allow or deny the traffic, what information it uses. So I got one question from Binay. He has asked, layer 2 is a, at layer 2 we have a MAC address, we have a source MAC and destination MAC, right? So you know, Binay, we can also deploy firewall as a layer 2 firewall, and we can define the ether type ACLs. Okay, ether type access control list. Like in Cisco SA firewall, if somebody has worked, we can deploy on the transparent mode. Your Palo Alto Firewall also we can deploy as a layer 2 mode, and at that time it will act as a layer 2 switch. It act like a layer 2 switch. Okay. Now let me go back to that statements again. So a firewall is a network and hardware based network security systems that control incoming and outgoing network traffic by analyzing the data packets and determine whether they should be allowed through or not based on the rule set. So what is this rule set? Rule set is the access control list. What is packet actually? What is packet, guys? Anil, I take your question. Okay. At the end, I'm going to discuss this next generation firewall and legacy firewall, so you will get the idea on that. Don't worry. Now let me just tell you what is packet. So generally what happens basically, do you know how generally data is created? So you know, on your data we have a layer 7 information. Then this layer 7 information wrapped inside the TCP, and TCP generally wrapped inside your IPv4 header, and this IPv4 header is encapsulated inside the Ethernet header, and this Ethernet header is encapsulated inside the frames, right? This is how the wrapping happens. And your entire information starting from this IPv4 till layer 7, this is known as packet. You can also share like layer 2 information also as a packet, but generally with layer 2 information it is known as frame. So packet is your layer 3 header, which is your IPv4 header or IP header, then your TCP header or UDP header, and the layer 7 information. Okay. So what it used to, it will analyze the data packets. Means what it will do, analyze the data packet means it will analyze your layer 2 information, layer 3 information, layer 4 information, right? And I'm not putting here layer 2 much, because generally we used to deploy firewalls as a layer 3 device. So layer 3, at layer 3 what it will basically analyze, or it will get the information of source IP, destination IP, and layer 3 protocol number. At layer 4, it will focus on source port and destination port field. It will check that particular data, and what it will do, it will make the decision. It needs to allow the traffic or it needs to deny the traffic based on the configured access control list or the security policies. So I think the definition of firewall is clear. And guys, how the parsing happens, that's the discussion of your packet flow. How it will do the layer 2 parsing, layer 3 parsing, everything I will cover. Don't worry on that. Okay. Whatever I have discussed just to explain you what is firewall. And I hope now you will understood the what definition of the firewall. How it is doing the parsing, how it will read the layer 2 information, and how it looks like. That's the discussion of your packet flow. And let me just show you one information just for the knowledge purpose, so you will get the whole idea. Okay, how I will basically give you that details. Just give me 1 second. I'm just opening one of the so when I will discuss your packet flow, I will tell you how Palo Alto 5 going to process the TCP send packet, how it has start reading the information, because these are the live logs I have taken from the Palo Alto. How it is reading your layer 2 header, then layer 3 header, which is IP header, and how it is reading your TCP header. Okay, so it's a part of your parsing, and I'm going to cover how it is analyzing the TCP options, right? Okay, so that I will discuss later, but I hope this is clear now. Definition of the firewall. It is clear to everyone? If yes, then write on the chat. Okay, cool. Now, a firewall establishes a barrier between a trusted network or a secure internet network and the another network, which is internet, that is not assumed to be a secure or trusted network. Means what firewall generally used to do. This area is known as LAN area, right? Local area network. And whatever the users are available here, we have a trust on these users, because these computers basically have a security postures at per your organization, right? You are managing all these particular computers using the domain controller. Do you know what is domain controller, guys? Or AD server, Active Directory servers? Because all your computers is managed and controlled by the domain controllers in an organization. They used to basically configure the group policies, and that is the main reason you are not allowed to install the unnecessary softwares, right? You will have lots of restrictions on them, because these computers controlled by you and you have a full trust on them. So this area known as local area network. Do you have any trust on the WAN over the internet? Because in over the internet we have good users as well, who is over in the internet for doing some business, and we have a bad users as well. Bad users, so I can say hackers. And what is the main intention of these hackers? Hackers always try to steal your information. They will always try to harm your system, harm your infrastructure. So on the basis of these particular parameters, in the firewall domains, we have some type of areas, like a area which is inside or trust. Inside or trust, let me write down here, inside zone or trust zone or land zone. And always, let's take an example, this interface, let's say this interface Ethernet 1/2, then I will put my interface Ethernet 1/2 into this particular zone. It is just the name, because we will use these zones on my security policies. Okay, and with the name, this inside zone, which means this is the most secure area, most trusted area. Why we are trusting on that area? Because this area controlled by our organization, and whatever peoples are there, whatever computers are there, these computers are designed and configured as per our organization policies, and we have a full trust on them. So these type of areas, or this particular area where we have these type of people, we will always put in a inside zone or either in a trust zone. The area or the interface of your firewall who connect you with the internet, that particular interface we will always put in a zone called outside or in a zone called untrust or a zone called internet or a zone called WAN. Why we have these type of names? Because this is the area where we will not trust on anyone, because in internet we don't have any trust. Maybe the person, maybe whatever the persons are available here, maybe he is an attacker, maybe he can basically harm your computer, harm your system, right? So that's why this particular area is known as a part of outside zone or either part of untrust zone or internet zone or WAN zone. Now you may ask why we have a different type of names, why we are not limiting our discussion till inside and outside. So guys, this inside and outside, it's a Cisco terminology. Who is Cisco? Cisco is also a firewall vendor. And your trust and untrust, it's a terminology from the Palo Alto. Okay. So because here we are discussing the general information of Palo Alto or general information of the firewall, so that's why I have covered. Like if you will see inside or trust, do not worry about it. Means you have to know, oh, this is the area where I have my LAN users. Outside and trust means we have to know, oh, this is the area where my firewall is connecting with the internet. So what firewall is doing? Firewall basically establish a barrier, or I can say it's a wall between a trusted zone and the untrusted zone. And here, what it will do, if any of the users from untrusted zone try to communicate with the trusted user, firewall going to block that connection right away until we will allow. Now you may ask why we need to allow the traffic from outside towards the inside. And so from outside to inside, we never allow. From outside to inside, we never allowed that traffic. And because we will never allow that traffic from outside to inside, that is the main reason we have basically invented one more zone is known as DMZ, demilitarized zone. What this zone basically used to do, if you will go here, in this particular zone, I always kept my web servers or the internet facing servers. Now you may ask why we have to basically put these type of server, because let's take an example. Your organization is a company A and you are dealing with some type of e-commerce business. Let's take an example. You are selling some sports goods. And now let's take an example. This particular user wants to purchase some type of sports articles from your website. What they will do? He needs to access your website, right? So what he will do? He will basically send that request into your firewall, and your firewall will forward this request over this web server, and this web server will reply with the content. So in these type of scenarios, we need to also allow the traffic from firewall from internet towards the type of servers, towards these your internet facing servers, towards your web servers. So now you got the point here why we need to allow the communication from internet towards your servers or towards your LAN area. It's not exactly LAN, it's a DMZ, towards your DMZ, right? Now you may ask why we have not kept all these servers inside this inside zone only. So for an example, let's take an example. Both of these interfaces are part of inside zone. This is just for example. Okay. And through this firewall, we have allowed the access of these servers towards this particular internet user, because this user wants to do some type of business with us. And on the inside, we do have these particular computers. And rather than they are connecting like this, let's take an example. These servers, they have connected from this switch like that. And let's take an example on this particular web server. We are having one type of vulnerability. There is a one vulnerability available into this particular web server. Let's take an example. It is having cross-site scripting vulnerability. Means this server, this web server is basically have this type of vulnerability. Somebody can launch the cross-site scripting attack, or maybe this particular server have some type of PHP vulnerability, or the web server rendering vulnerability. And because it is having that vulnerability, so what this particular internet user, let's take an example. Now this internet user is some type of hacker, and what he is doing now basically he has basically tried to he had just exploit this vulnerability on this server, and he just gained the unauthorized access of this server. Now he has a full control on this server. Now what he has done, because he has a full control of this server, he got the CLI access of this server. So what he has done, now he has basically he has just copied one of the malware into this server, and he has now tried to send this particular malware towards these computers. And there is a high chance now this particular malware is doing the lateral movement, or maybe after gaining the access of this server, now maybe he's trying to exploit, he will try to check if these particular computers or the user systems is also vulnerable for any vulnerability. Then he will may try to exploit these particular vulnerability as well. And here for this type of this type of attack, we are not having any type of control, because it's just a switch. From this server, we can move our attack towards these PC easily, right? We can do the pivoting and double pivoting type of attacks as well. It is possible, guys, or not? Lateral movement of your attack is possible in this situation, because we have your computers and we have your public internet facing servers into the same zone. So it is totally possible, right? Now, what is the solution for this? So to avoid such type of problems, what they have done, they have created a dedicated zone called DMZ. And they have a dedicated zone called inside, and in inside zone we have our actual users, actual computers. If one of our server is exploited here, then and if that attack now trying to move towards your PC, what he has to send that request towards the firewall, and now through this firewall this request go towards your PC. But here we will put the restriction. If any of the server trying to reach these computers, what we will block that traffic right away, because we have that type of rule on the firewall. And by default, firewall will not allow any type of traffic from inside or DMZ zone. They will not allow, means inter-zone communication is not allowed on the firewall. And what is inter-zone communication? Means communication happening between two zones, and we will discuss that details in depth in your security policies, because we have a two rules on the firewall: intra-zone default rule and inter-zone default rule. Okay, so now at least now I have now, I am not able to save my servers, but I have saved my actual users, right? So that is the reason we used to introduce the demilitarized zone or DMZ zone. Now, tell me one thing. So guys, DMZ is a zone where peoples from internet, they will also reach and they will access the web content, and your inside users will also access these servers. So now you can ask why in these PC1 or PC2 needs to access these servers. Let's take an example. PC1 and PC2 hold by the network administrator, network admin. And now this network admin wants to update the web content on this particular servers. So what he will do, he will access these servers via SHS, and people from internet, they will access these servers over TCP port 80 or either on TCP port 443, like your HTTP traffic or either HTTPS traffic, right? So you can say DMZ or demilitarized zone is a less secure zone in comparison to outside, but it is more secure in comparison to outside zone, but it is less secure in comparison to inside zone. So means it is a middle security zone or the balanced security zone. I hope now these points is clear to everyone: outside, inside, and DMZ. If yes, then write on the chat if you got the points here. And I hope you have a now clear understanding why we use demilitarized zone. Okay, that's great then. So now this covers this particular, what is firewall? So as I have mentioned, what firewall used to do? Firewall generally allowed the good traffic and it will basically block the bad traffic. This is also one of the more responsibility of the firewall. If I will tell you couple of vendors for the firewalls, so we have a Sonic Wall, Palo Alto, Juniper, Cisco, Checkpoint, Stonesoft, Fortinet, WatchGuard. There is a hell lot of vendors are there, and I will mention what are the vendors who has a very good market cap. Now let's try to understand the stateful inspection, guys. Very, very good topic. And in your interviews, they will ask, what is stateful inspection? Sumant, regarding this cross-site scripting attacks, you can basically search over the internet. You will get lots of articles. And even though in your vulnerability session, when we will discuss the vulnerability protection, I will launch this cross-site scripting attack on the Amazon website. Okay. Now, now let's try to understand the stateful inspection. So, before stateful inspection, let me just tell you what is the stateless behavior of the firewalls. So guys, For simplicity, I'm just removing this DMZ part here from here. Now we are discussing most important part, guys. Let me remove this internet user as well, not required at all. One user is enough. Okay. Now let's take an example. We have this type of setup. But instead of firewall, let's take an example. We have a router. This is my router now. This is a router I'm having. Siraj, so you can ask that DMZ question after when in your in the Q&A session. Okay. Now let me just move further towards the stateful inspection. So guys, anyone have worked with the Cisco routers? And in your routers, if you want to allow or if you want to deny the traffic, what will happen? We used to write the access control list, right? By using access control list, we used to allow the traffic and we used to deny the traffic. Now, let's take an example, guys. We have a facebook.com which is hosted on TCP 443. IP address is 151.100.100. And now on this particular page, let's suppose, or let me instead of facebook.com, let's take an example of journal server actually. Journal server will help you. Let's take an example. We have a server 100 over the internet, and on that server what I am having a file of 2 GB. It's a .mp4 file, and now I want to download this particular file from this server 100 on this PC. So what this PC will do now? So guys, now on this PC I will open the web browser and I'll just type https 151.100.100 this IP. What is the first packet this particular PC will initiate towards this server? The very first packet is TCP send because it's that server hosting or TCP, right? In TCP, what will happen? First TCP three-way handshake will happen, and once TCP three-way handshake will complete, what it will start the your SSL handshake, and once SSL handshake will complete, then what it will do? And after that, it will start with the normal communication. It will start downloading this particular file, right? So it has sent the TCP send. And guys, for just for the simplicity, let's take an example. It's a web server, okay? Because I don't want to go in the SSL right now until you will got the idea. So let's take an example. It has sent TCP send request towards the router. Now what router used to do? When router received this packet, so it will receive this packet at Ethernet 1 by 2, right? So it will put this packet into the ingress processing. It will increase the interface counter by 1, right? And it will basically check the routing, it will check the net, it will check the access control list. If we have a policy based routing, then it will check the PVR policies, it will check the SEP policies, right? And it will check the SEP table, and after that it will do the ARP lookup and all, and after that only it will do the, it will basically exit out this particular traffic through Ethernet 1 by 1 interface, right? So router has exited out this traffic towards this server. And when this router do the processing, what it used to do, in case of Cisco routers, they have around 27 checks. They have around 27 checks if we will use all the features of a router. And the main checks on this router is the routing lookup, your NAT lookup, your access control list. These are the main checks. Out of these 27 checks, router, let's take an example. If router needed around 2 seconds of time, hypothetically, to process this particular entire TCP SYN request, then routing, NAT and ACL checks, they need entire 1 second. Now this packet reached to the server. Now what server will do? Server will reply. What we will receive in the reply? TCP SYN plus ECK? Yes, no. We will get the TCP SYN plus ECK packet. Now again, this router basically do these 27 checks. Again, it needs a 2 seconds where routing, NAT and ACL, it needed around 1 second. And after that, it will basically sends the acknowledgement. This is the ACK request. This ACK request again go through with these 27 checks, right? And once they will complete this TCP three-way handshake, what will happen? Now TCP connection is in established state. And now what they will do now, it will basically sends the HTTP GET request. HTTP GET will also go through all these 27 checks. Then he will get the reply. HTTP GET request, HTTP response, and like that they do the communication, right? Multiple HTTP request and response you will see until you will download this entire 2 GB of file. Let's take an example. Between this PC and this particular server, they have basically exchanged 200 total request and reply packets. Means all these packets, they have exchanged around 200 packets. So if this router, when this PC has downloaded this 2 GB of file, why this router? How many seconds is needed to process this entire communication? Around 400 seconds, because each and every request needs to go through with the 27 checks. Okay. So this is the behavior with regards to the router, and router is a stateless device. Router is a stateless device. So with regards to this router, guys, this process is clear. Any doubt on this process? Now let me just tell you what is the behavior with regards to the stateful. Now we have a same type of setup. We have a same PC here. 10.1.1.100. Now I'm just putting the firewall directly. Ethernet 1x2. It's a part of inside. We have an internet. This is Ethernet 1x1. This is a part of outside zone. Internet service provider. And here I have a same server. Server 100. That server 100 IP address is 150. 1.1.100. It is running on TC port 80 and it is having the same 2 GB of file. And guys, if somebody wants to understand what are these 27 checks on the router, read these particular documents of a router, because I'm not an expert on routing. I am a hardcore security guy. Read the Cisco documents, you will get 2 GB of file. Now guys, we have this setup. Now here you have to put your full attention, okay? Because this is most important. An entire batch, basically all your classes has a dependency on this communication now. So I will request, put your full attention here on this particular discussion, because here we are discussing so many things. Now, this particular PC has sent one request, which is a TCP SYN request. And guys, let's take an example. It's a Palo Alto Firewall. Okay, because I'm discussing with regards to PA firewall. It will send TCP SYN request. Now firewall do the processing of this particular SYN request. And once it will do the processing, it will forward this particular request towards this server. Now, when firewall receive this particular packet on Ethernet 1x2 interface, what it will do? It will start the processing. And how it will do the processing? The very first thing which is done by the firewall is, what it will do? It will basically process the packet at ingress stage. The second thing which is done by the firewall is flow lookup. Third thing, session setup or silo path. Then fast path, and fifth one is, so guys, I'm just putting, it will also use to perform the app ID, content ID, and seventh one is forwarding. Forwarding is also known as egress stage. That's how your firewall or Palo Alto Firewall used to do the packet processing. And this is the 7 stages of your packet Palo Alto packet flow. Ingress stage, flow lookup, silo path or session setup state, fast path, app ID, content ID, and egress stage of forwarding stage. Now, guys, just remember one thing. I'm just highlighting this detail, okay? Because in TCP SYN packet, it is not having any type of layer 7 data. So because you know app ID and content ID is only processing your layer 7 information from the packet, and your TCP SYN packet, it is not having any layer 7. So these two stages will be not there for your TCP SYN packet, just remember. And as of now, you just need to know the stages: ingress stage, flow lookup, session setup or silo path, then fast path, and forwarding stage. Now, in the silo path stage, I am just putting here, in the silo path stage of Palo Alto, what it used to do in the silo path, the major checks, which is routing table lookup, your net lookup, your security policy lookup, is done by the in the silo path only. Okay. And guys, just for the same example, this firewall, let's suppose it's take a 2 seconds. When your packet going through ingress stage, flow lookup, slow path, fast path, and forwarding stays. It's needed around 2 seconds of time. Okay. But what this firewall will also do, because your Palo Alto firewall is a stateful firewall. Your Palo Alto firewall is a stateful firewall, right? And what it used to do, all the stateful firewalls, they used to maintain the session information. They used to track the state of a connection or a state of a flow. Whenever this, because this PC is trying to communicate with this server, so for the entire communication, this firewall maintain a session. And how it will basically create a session, your Palo Alto firewall will create a session. So what it will do, because in TCP send request or on this particular packet, we have a layer 3 information, we have a layer 4 header, right? So what is the layer 3 information? From layer 3 header, what we will get? We will get the source IP address. What is the source IP here? 10.1.1.100. What is the destination IP address? Means your source IP, your destination IP, which is 150.1.1.100, which is destination IP. Then your layer 3 port number. What is the layer 3 protocol number for TCP? 6. Layer 3 protocol. At layer 4, we have a source port and destination port. So what it will do? Let's take an example. This PC has randomly chosen a port number, source which is 3050, and destination port is always fixed, which is 80. And we know this firewall know he had received the traffic on Ethernet 1x2 interface, and Ethernet 1x2 interface is a part of inside zone. So he will also include the source zone detail, which is inside. Means now these are the 6 tuple of your session table or the connection table or the state table. These are the 6 tuples: source IP, destination IP, layer 3 protocol number, source port, destination port, and source zone. My firewall basically remember this particular information for this particular communication, and it will maintain this particular details in a session. What it will maintain this detail in a session. And now guys, whatever request, now when this particular server, he will reply. So he will reply with TCP send plus ACK, and now he will basically sends the ACK. TCP acknowledgement packet, and after that they will exchange the HTTP related packets, right? HTTP request and HTTP response, right? You will see lots of packets here and there. Now what they used to do generally, now whenever my firewall receive a, now whenever my firewall receive any subsequent request packet or subsequent reply packet, so this is a reply packet and these are the request packet, then request reply, what it will do, it will bypass the slow path for subsequent request and reply. And why it is bypassing this particular slow path stage? And major checks available in the slow path only: routing, net, security policies. what it used to do, it will bypass these particular checks. Why it will bypass? Because it has created the session on the basis of source IP, destination IP, layer 3 protocol number, source port, destination port, and the source zone detail. It has created that particular session. And because it is bypassing the silo path for all these particular packets. And as I have mentioned, if my firewall, when firewall is processing the packet at ingress stage, flow lookup, silo path, fast path, app ID, content ID, and ingress stage, then it needs 2 seconds, where your silo path is taking 1 second out of these 2 seconds. And because we are bypassing this particular check for subsequent request and reply packets. And let's take an example. They have exchanged 200 packets, like they have exchanged in case of router. When they are downloading this 2 GB file, what will happen now? To process these 200 packets, how many time taking by the firewall is 201 seconds only? Guys, this is clear. Don't worry about the stages. I know you will not able to understand the stages as of now, but when we will discuss packet flow, you will get the whole idea on it. So it will bypass your routing engine, routing table, net lookup, and security policies from the silo path, because it's a part of silo path. There are so many other things also available in the silo path. I have not discussed these things because we will discuss later when you will have the whole idea of each stages, how they used to do the packet processing. So at least, because on this firewall it's a stateful device and it is maintaining the state of a connection in a table called session table or the connection table or the state table. And what it will do, on that table it will store the source IP, source port, source IP, destination IP, layer 3 protocol number, source port, destination port, and the source zone details. Because it will store that information, it will identify all the subsequent request and reply packets on the basis of that information. And because my firewall know, oh, this request belongs to this session, so let's bypass the silo path. And whenever it will bypass the silo path, means it is saving the time. It is saving the time, right? Because these are the major checks which really needs time, because maybe you are having 10,000 policies, security policy in your firewall, maybe you are having 2,000 routes in your firewall, right? And they really needs time. So because of stateful inspection, we have reduced the, and we have completely changed the inspection behavior as well, because we have bypassed couple of checks which is not needed. Because once your security policy checks is passed for this flow, then we can bypass for the remaining communication, because their source IP and destination IP, source port, destination port, protocol number, and source zone will not going to change. And if it is not going to change, if we are allowing that traffic on the firewall, then every time whenever it will do the lookup on security policy, it will allow, right? So better we can just do the lookup once and we can bypass for the remaining communication. So here, your router took around 400 seconds for processing, but your firewall is taking only 201 second, means we have saved around 199 second. Means because of this stateful inspection, your firewall throughput just increased by double in comparison to your routers. Okay. So this is one of the analogy which I generally tried while explaining the stateful inspection. Now let's go here. Now let's try to understand. So guys, what generally your firewall used to do, or what is your stateful inspection? What in stateful inspection, it checks your layer 3 and layer 4 information. At layer 3, source IP, destination IP, and layer 3 protocol number. Guys, what is the layer 3 protocol number for UDP? Write down on the chat if somebody is aware about that. What is the layer 3 protocol number for UDP? 17. What is the layer 3 protocol number for ESP packets? What is the layer 3 protocol number for GRE packets? And what is the layer 3 protocol number for ICMP? So Saruk, you have answered correctly. For ESP, it's 50. For GRE, it's 47. For ICMP, it's 1. And what is for AH? Anyone aware about this AH protocol? AH is 51. Okay. So we do have a lots of layer 3 protocols. Okay, just remember. Now, and the layer for information within an IP packet and store that information in a separate table referred as a state table of the firewall. So guys, if I'll say state table, if I'll say the session table, or if I'll say the connection table, all are similar. If I'll say session table, it's a Palo Alto terminology. Connection table, it's a Cisco terminology. If state table, it's a checkpoint terminology. Okay, so what it is checking layer 3 and layer 4 information from your IP packet, and it is storing that information into the session table. All the traffic flows through the firewall will be compared or inspected against the state table entries. Means whenever my firewall receive a packet, what it will do, it will basically extract the layer 3 information from the packet, layer 4 information from the packet, and it will basically match this layer 3 and layer 4 information from the state table. Means it will use to perform the session lookup or the connection lookup on the connection table. Because when it will do the lookup into the connection table or state table, then only it knows, right, this packet belongs to the existing connection, or this packet basically is a new request. It maintains the state of a connection when packet is traveling. For the appliance, a stateful firewall maintains the state of a connection in the state table of the firewall. After adding information in the state table, it forwards the packet to the destination. When it receives the reply packet, it matches the packet information to the state table. If I will receive the reply packet, if match the packet is accepted, otherwise drop. What it used to do, now whenever it will receive, once it will create a session, right, so whatever request you, whatever reply you will get, or whatever request you will get, what it will do, it will match each and every packets against these requests and replies. And what it will do, it will basically bypass the slow path. It will bypass the slow path completely. Okay, just remember. So like that, it will write down the information. Okay, now let's try to understand few more details. A stateless firewall watch the network traffic and restrict or block the packet based on source IP, destination IP, source port, destination port, layer 3 protocol. A stateless firewall do not maintain the state of a connection or session. Like your ACLs on your Cisco routers is the example of a stateless firewall. Your Windows firewall, whatever we have discussed in the initial time, I have created one inbound rule, right? It is example of a stateless firewall. Access control list in your routers is an example of stateless firewalls. Okay, now, so guys, now let's try to understand one more thing. See, this particular stateful technology is developed in 1993, and this particular technology developed by the person called Nirzuk. He was a tech engineer on checkpoint. So the actual owner of that particular stateful inspection is the checkpoint firewalls. So checkpoint is the firewalls who has introduced a stateful inspection first time in 1993. And after 1993, in 1994 onwards, all the vendors like your Cisco, that time they have a Cisco ASA, your Juniper, all the other vendors, what they have done, they have basically deployed this stateful inspection techniques on their devices. So the actual owner or developer of this particular technique is Checkpoint, and the person who has done this is Nirzuk. Now, who is Nirzuk? He is a founder of Palo Alto Networks. So what he has done, initially he was a part of NetScreen, which is nowadays known as Juniper Networks. So initially he has worked with the Juniper Networks or NetScreen. Then he left NetScreen and he has worked in the Checkpoint. And after that he left Checkpoint and he has basically created his own firewall, which is Palo Alto Networks. So he has basically introduced Palo Alto Networks in 2002. He had launched this device in 2002, but that firewall have lots of bugs. It has lots of problems, so he has stopped, and now he has again done some R&D, upgraded the things, and then he has launched the Palo Alto Networks again in 2005. And when he has launched this Palo Alto firewall in 2005, Palo Alto is the first firewall who has a support of application ID, app ID feature, your content ID features. Means it has lots of very, very nice features within the box. Means it has lots of layer 7 features. And because it has these beautiful features, just within 3 years of time, in 2008, Palo Alto become the market leader in the firewall industry. And from 2008 till today, Palo Alto Firewall is the market leader. And he is leading the firewall industry since then. Okay, so this is the little bit history of your Palo Alto networks. And if you will basically type here Nirjuk, so you will get the idea. He is the person. You can basically get the details. Author at Palo Alto Networks and all, right? So you will get the whole lot of details with regards to that person. So he has worked with Checkpoint. Now he's a Palo Alto, right? He's in Palo Alto. Okay. Now, so if you will see this particular diagram, now let me come back here. So we have discussed this stateful inspection. Okay, so as I mentioned, when he has launched the Palo Alto firewall first time, it was the first firewall who has a support for app ID, application identification, user ID. You can able to implement the user based policies, and it has a support of content ID just within the one box. All these features you will get in the same box. And if you will check the Gartner report, you can see Palo Alto is the market leader. And after that, we have Fortinet, then we have Checkpoint, then we have Cisco. Okay. If you want, let me just give you the Palo Alto product portfolio, guys, in a brief. So in Palo Alto Firewall, basically what they have a three division. They have a Strata, Prisma, and Cortex. Your Strata basically includes the next generation firewalls and the Panorama. So your Palo Alto Firewall and Panorama, it's a part of Strata solution. Then they have a Prisma solution, so which includes your Prisma Access and Prisma SD-WAN. And these are the cloud-based solution. Then they have a Cortex XDR. This is for threat intelligence, detection and response, right? For automation, network traffic and behavioral analysis and all, right? And Cortex is also a data. You will also have a DLP solution, data lake solution and all, right? Means the main focus towards the endpoint security or and the cloud-based log storage. And the main focus of your Strata to implement firewalls in your hybrid data centers, internet perimeters, branch and mobile, IoT and 5G and endpoints. Prisma, generally we have for securing your public cloud traffic and the SaaS application traffic. So we have a cloud-based log solution under the Cortex, cloud solution from Palo Alto, which is Prisma Access and Palo Alto SD-WAN, which is also known as Prisma SD-WAN or CloudGenix SD-WAN. And we have a Palo Alto network security solution, which is Palo Alto next generation firewalls and Palo Alto Prisma. So if you will see, if you want to secure your enterprise network, which means your Strata, which includes your Panorama, your firewall, because nowadays all your Palo Alto firewall, they are also comes with the machine learning. Okay, they have a support for machine learning for analyzing the threats and all. Okay, you have a Panorama, we have a wildfire features, global protect and SD-WAN. SD-WAN also they have put inside the securing an enterprise. Then you can secure the cloud. For securing the cloud, we have a Prisma Cloud and Prisma SaaS. For securing the features, we have a Cortex Data Lake, Cortex XDR, and Cortex XOR. Yes, so this Strata Cloud Manager or SCM, generally, what the plan is going on at the Palo Alto, and they are planning to remove Panorama in future. In future, you will see SCM only. So it is not almost similar, but because this SCM is still under the development phase, Nishant. Okay, so in future you will see the same type of GUI, because Palo Alto generally prefer to have a similar type of graphical user interface. Okay, so still there is a hell lot of bugs you will like available into this particular SCM. So guys, this is the basic portfolio. Now let me just give you the idea. So like this is some more information if you want to read. Like Palo Alto is a Palo Alto name. Why he have picked the name of firewall Palo Alto Firewall as a Palo Alto? Because he have get this name from the with the name of one of the city in California, right? PA is a like USA multinational company, so you will get all that detail. Palo Alto Next Generation Firewall named Gartner Cool Vendor in the year 2008. So from 2008, it's a #1 firewall. This article I will not discuss now, guys, because it's a part of SP3 inspection and all. So I will discuss later. Because today I don't want to go on that much depth. Now let's try to understand the Palo Alto operating system and Palo Alto hardware appliance. Okay. So guys, the operating system which is running in your Palo Alto firewall is known as PAN-OS. I forget to clear this information because it is from the last session. Okay, now, so guys, let's try to understand what is PAN-OS. PAN-OS stand for Palo Alto Operating System or Palo Alto Networks Operating System. So what they have done and how they have built the operating system. So guys, to run any type of operating system, the very first requirement is the kernel. You need a kernel basically. So what they have done, your Palo Alto, they have basically they have basically utilized the kernel of one of the Linux flavor, which is BSD Linux. BSD Linux is a open source. It is a open source project. Means open source means anyone can do any type of modification into this BSD Linux OS. So what they have done, Palo Alto basically taken this BSD Linux. They have done some customization. They did some customization on the BSD Linux. Okay, and what they have done, so they, like, we have a BSD Linux kernel. After customization and on top of this particular kernel, what they have basically added the PAN application or Palo Alto application, and the whole thing become the PAN OS. So your Palo Alto operating system is the customized version of BSD Linux. So guys, that is the also main reason. If you want to do some extra or very high level troubleshooting in your Palo Alto firewall, then what you have to do, you have to log in into your Palo Alto firewall as a root user. What do you mean by the root user? Let me just show you, because my Linux is already running. If I'll go on my Linux, right now you can see this icon, which means I am a normal user. If I will just mention it, sudo -i, and whenever you will see, now I am a root user, I can do any modification on this particular Linux box. And because it's a Linux, and if you will run this command top, we have all these processes, right? You can see all these processes. These processes known as daemons, and in your Palo Alto firewall is also all these daemons are running. In your Palo Alto firewall also all these daemons are running, because the kernel of your Palo Alto operating system is based on Linux. Let me show you all these particular processes basically. Just guys, give me 1 second, please. So, like, do not worry about the commands, whatever I'm running. If you will run this command, show system software status, see, all these processes are running. These are the daemons. And why I can able to take the SHS on my Palo Alto firewall, because this SSHD service is running. SSHD daemon is running. I can able to take the GUI access because this BEF server daemon service is running. There is a meaning of each daemon. We have a route the daemon who will basically responsible for routing related tasks, who will maintain the routing table, route D, right? So I will tell you all these daemons as well, but I just wanted to show you these are the daemons which are available in your Palo Alto firewall, because Palo Alto firewall kernel is based on the Linux only. So guys, just remember, in your Palo Alto firewall, we have a two planes. We have a management plane and we have a data plane. What management plane, what it will do? Management plane, we will be having for doing the config management. Any type of configuration we will do. by logging to the management plane, your reporting and your logging. Generation of logs and reporting we will done with the management plane, and your data plane, it will process the users traffic. All the users traffic is processed by the data plane. And apart from these responsibility, your management plane is also responsible for daemon management, because if we have 100 daemons in your Palo Alto firewall, then 85 daemon is a part of your management plane. Means 80% daemons is running in the management plane, because your management plane is a hardcore BSD Linux kernel. Okay, so guys, this is the some information with regards to the operating system or the operating system of Palo Alto Firewall. Now, guys, just remember one thing. If you are, and let's take an example, you are having Palo Alto 200 series box. You have a Palo Alto 400 series box in your environment, and you have a Palo Alto 3400 series box, and we have a Palo Alto 5400 series box, and we have a Palo Alto 7500 series box. Then remember guys, for PA200 we need to download the dedicated OS. It's not like that same operating system we can run into 200, 400 or 3400 or 5400. No, what if you are having 200 series box, then you have to basically download the 200 series Palo Alto operating system. If you have a 400 box, then you have to download the 400 series pan OS, because pan OS compatibility depends on the pan OS compatibility depends on the hardware appliance, because maybe on 5400 series they have couple of some extra features. So maybe whatever pan OS you will have for this series, it has these features built in. Just remember, okay? So whenever you are trying to upgrade your firewalls in your infrastructure, what you have to do, whenever you are upgrading, you have to make sure, if you are having 400 series box, then you have to download that particular operating system versions. Even though guys, even the similar thing applied for the cloud service providers like your Google Cloud, GCP, your AWS Cloud, your Azure Cloud, your Alibaba Cloud, right? For these cloud vendors also, Palo Alto have created a dedicated operating system images, and you have to just install these images only from their marketplace. Just remember, it's not like that you will just download the single operating system and you can run. No, it's not like that. If you, we have a dedicated Palo Alto images for virtual appliance as well. Okay, just remember. So this is all about the operating system. And guys, one more thing, the latest pan OS is 11x. This is the most latest operating system, which is 11x. But why we were not using 11x in our training? Because it is having lots of bugs. It's not recommended at all to use. So what I am going to use on my labs, which is Palo Alto 10.x, and most probably I'm going to use 10.2.9 H1, because this is the most stable version of Palo Alto. Now you may ask, what is the major difference between 10.2 and 11? There is no much difference. First of all, with regards to this training, there is no much difference, but with regards to the tech troubleshooting training, there are some differences, and I'm going to cover this part. It's not N, it's H, guys. Okay, so sometime whenever you will basically download the operating system pan OS, you will see this thing, like we have a 10.2.9 hyphen H1, where this 10.2 is known as major version and 9H1 is known as minor version. Okay. So now let me tell you some more information, guys. Or let me explain you from here because I have a GUI right now. Softwares. I'll go here and I can track all the versions from this particular GUI as well. Right now you can see I'm running 10.2. H hyphen 2 10.2.4 hyphen H2, which is downloaded and it is also currently installed, right? So guys, one more thing. See here, if I'll go little bit down, if you will see, this is the current version which is up and running, and I do have 10.2.0 where it is. Just give me 1 second. Let me just check, click on check now. So I will basically able to check the latest version, and even though Palo Alto Pan OS, I will go through with this, guys, not now. Okay, it's too early to go there. So if you will see, these are the versions available right now. Now if you will see here, I want to give you some idea with regards to the base versions. I'm not sure why I'm not able to see the base images here. Yeah, so if you will see here, we have this 11.2.0. This particular image size is 1167 because it's a base image. Base image size is always higher. Then we have a subsequent version on 10.2.0 series, which is 10.2.1, which has a 570 MB. We have a 11.1.0. This is a base image. Then we have a further version still here. These are the minor release into this particular series. Okay. So because you will see the base image and these particular versions there. Because I'm running 10.2.4, I'm not sure why I'm not able to see 10.2.0. that image, somehow it is not available. Maybe I have deleted because I have done lots of customization on it, right? And you can, okay, because the thing is why I can see because I have uploaded this 10.2.0 manually, because as I remember, I did this work manually, right? Because right now I'm running 10.2.4. Why I'm running this 10.2.4? See, to run this 10.2.4, there is a requirement. I must have this base version. Without base version, I cannot able to run this image, because this base version at least I needs to basically upload on the firewall. Okay. Because as I remember, this particular firewall I was having on 11 series, but it was having some bugs. So I have just downgraded with 10.2.4. But I know the most stable version is 10.2.9 H1. So I will basically upgrade this particular firewall till that version in your next class. Okay. I will just click on downloads it. So this is, guys, some information we will be having with regards to your Pan OS operating system. Here generally 10.11.0, this is known as base version, and this one hyphen H4, they are known as basically interim versions or the minor releases. Now let's try to understand with regards to your hardware appliances. So in Palo Alto Firewall, we have a three type of appliances. We have a physical appliances, like these are the example of physical devices, where I have put this is a Panorama M200, this is Panorama M500 and 600, right? This is a data center box of 7000 series. This is Palo Alto 5200 series. This is 3200 series box, 800 series and all. So we have a physical appliance. We have a virtual appliance. These are the VM devices, VM series firewalls, and we do have a CN series appliance. CN series appliance are the very new firewalls. These firewalls are the cloud native series. They are the cloud native appliances. Means we can run these CN series devices over the public cloud or the private clouds using the as a Docker images. Because nowadays we have a very good market of Docker and Kubernetes, right? And we can able to control these firewalls, CN series devices with the help of this Docker and Kubernetes clusters. Okay. Now, what you need to know about these appliances? So what you can do, guys, you can let me just write down these appliance details. So Palo Alto Firewall divided their appliances into three categories. The very first category for the small organizations, a small size organization. Then we have a second series for medium size organizations. And they have basically created the third series for data centers or for enterprise customers. Now, in a small size organization series, what they have a very first series, which is Palo Alto 200 series. In this series, they have a two box, Palo Alto 220, and they have a 220R. Okay. They have a Palo Alto 400 series, which is a recently launched series. So you can think like that. This PA200 is a, let's take an example, first generation devices. Then Palo Alto 400 series is a second generation devices. They are the very new devices. 400 series, here they have a 420, 440 boxes. Now, so these are the two series are available for small size organizations, guys. Okay. And after that, they have a medium size organization details where they have a Palo Alto 800 series, where they have a 820, 850. And recently, to basically replace this 800 series box, they have introduced Palo Alto 1400 series. So like 400 series, then 1400, it's a quite new box, quite new series. Okay. Then for medium size organization, they do have a Palo Alto 3200 series. And recently to replace the 3200 series, they have introduced Palo Alto 3400 series. Now, which is a very new boxes. Remember one thing, or I'll just mention these points later. Now, for data centers, they were having Palo Alto 52 series, where they have a 5220, then 5250, 5260. I think 5280 also there, but we will check the data sheets. Then replace this 5200 series, they have launched Palo Alto 5400 series. And guys, nowadays most of the customers, they are migrating their 5200 series with Palo Alto 5400 series box. Okay, just remember. Then they were having Palo Alto 7000 series as well, and they have recently introduced Palo Alto 7500 series. Okay, so these are the quite latest series, guys, and you will able to found these particular boxes in the organizations. Before that, they were also having Palo Alto 2000 series. It is end of sale, end of life. They were having Palo Alto 3000 series, which is also end of sale, end of life. They were having Palo Alto 5000 series, which is also end of life, end of sale. These device you never found now. How you can check the details? You can go over the internet and type Palo Alto hardware software compatibility. I will cover later. Hardware appliance. Read the data sheets. From here you can do the comparison as well. So here it will open the comparison tools, right? And you will get the entire comparison of each box. I will recommend go through with this comparison. You don't need to remember this throughput and all. It's not your job to remember. When you will reach, whenever your organization reach out to Palo Alto, so Palo Alto sales engineers, they will basically recommend you the best box because they have couple of internal tools, and these particular tools they will use for analyzing things. Okay, now, so where is these firewalls one? I want the hardware appliances. Like they have a Palo Alto 7500 series. You can get the details. 7500 C, it has a throughput of 1.5 Tbps in terabyte, guys, with app ID. Interface support, they will support an interface with 400 Gbps. See how much capable of this box. Networking processor, it has around 7 networking processor. Means you can put external 7 network modules or interface cards. Layer 7 threat prevention, you will get around 1.44 Tbps. This is the box of 7000 series, guys. You can check it out. It is a blade chassis. See, it has these many fans. This is how this box looks like. Even though, guys, I have worked on this 7000 series, but I have not done anything with it towards the hardware side. I have did the configuration and all. Okay, so here you can check it out. Then we have a Palo Alto 5445 series box. See, 90 Gbps of throughput, 76 Gbps of layer 7 throughput. Right? Check out these details. Then they have a PA 400 series, 450R, PA 1415G, 5. This is for 5G. Okay, so these are the very new or very latest series actually. Okay, even though I'm working in one of the project where we are just migrating the firewalls like PA50 to 2020 with PA5410, and we are also migrating with PA5445. So I'm just handling two of the projects right now on that migration. So you will get the whole hell lot of things here. Check out these hardware appliance and all, you will get the whole idea. Okay, right now Palo Alto has a more focus towards the AI, artificial intelligence, or the machine learning implementation into their boxes basically. So they are now trying to create very powerful firewalls. See, AI powered devices, these are the AI powered devices who supports the AI and all. And from here you can basically check the mod throughput and all for each and every models. You can compare the things, right? You will get the whole idea. You can request the demo and also you will get the more idea on it. Okay, just open PA5400 series, read through it. So these are the data sheet, guys. You just need to go through with them. You don't need to remember anything here. Now they did lots of changes in their website as well actually. So 5400 series, right? 5450 will be there, 3400 series, 1400 series. These are the very new boxes. Then 400 series, and they have a more family, like they have a PA 220, right? 220R, 5200 series. So you will get whole idea like 800 series boxes. So whatever name we have discussed, they do have a PA 3000 series, but it is not in use nowadays. Then they have a ION devices. These are the Palo Alto SD-WAN devices. ION 100, 1000, ION 2000, 3000, and 3200 for SD-WAN. Then this is for Panorama M300 and M700. These are the most used Panorama nowadays. You can get the idea of end of sale. If you will click on this, you will get all the end of sale. Here you will get the dates, right? So this URL very helpful. So you will get like PAT20R. It is end of live date is 1st January 2030. End of sale, they will stop selling this device from next year. And what is the replacement for this PA220R? You can go with PA400 series R. 800 series, which is 820 and 850. It is, I think, ending this month. Yes, August, right? End of date for the support is 31st August 2029, and recommended version is 1400 series. M200 and 600 Panorama is also, they are retiring now in Feb 2024. It is already retired, and now they are migrating towards M300 or either M700. For 3200 series, because they have a 3220, 3250, 3260, 3220 with JetTP. JetTP stand for zero touch provisioning, and recommended version is 3400 series box. Then we have a Palo Alto 5200 series where 5220, 5450, 60 and all. Recommended version is 5400 series box. Then 7000 series, you can replace with that. 7050, replace with that. This is already like end of life, I think in 2019 only, this 3000 series, right? So like they do have a Palo Alto 5000 series and all, right? They do have a 2000 series as I have mentioned, right? And the recommended version is 1400 only nowadays. Okay, I'm putting this link, guys, so it will really help you. And I got one question for the designing and sizing. So designing and sizing, I will explain you later, okay? Because if I will start explaining this thing now, then it's become very difficult for peoples. You will get the idea here, like if you want to know the details with regards to any versions, you can basically check out into these links. Like here you will get the whole idea. You can read the overview and all. You will get the front panel details. All such details are available here. Box details and all. Okay. It has like, if let me just, if I will give you some idea, then on this box basically, these are your copper ports, right? Then we have a fiber ports. Then we have a HSCI port, right? This is the high speed fiber link which we will use as a HA2 interface. Then we have a HA1 interface and HA1 backup interface, right? HA1 ANV. Then we have a console port. We have a USB port. We have a dedicated management port, right? This is a Palo Alto PA 50 to 20. So you will get the idea here, all the things. These are your copper ports, then these are your fiber port or SFP plus ports. And we do have a QSFP plus ports as well, then HSCI port, auxiliary ports, right? So like that, you can also read through with these details, you will get the idea. Okay. Now there is a one more website I wanted to suggest, guys. So just give me 1 second. Where is this one? Palo Guard. Yeah. This is the also one more website, paloaltoguard.com. Always check out this particular website. And here also you will able to see the details of next generation firewalls like SD-WAN devices, legacy products and all. You will get all that detail. If you will click on product, next generation firewalls, you can basically read, you can click on 7. Let's take an example, PA5410. You will get the idea on this one. You can go with the firewall sizing survey and all, right? You can share your details. They will basically send you details and all. Here you will get the all the features, right? Read through with this feature, throughput and all, right? Networking features, a specification you can check out here, right? For PA 5430, 5420 and 5410. Check out the firewall throughput, threat prevention, IPsec throughput, maximum session, new session per second, virtual base and all, right? You will get hell lot of information here. Okay. So now let me just share you this link as well. Okay. Now, apart from these hardware appliances, guys, Palo Alto Firewall do have a virtual appliance actually. And these virtual appliance you can basically install into the private virtual cloud. Means you can install in any of the hypervisors. You can also install these virtual images on the public cloud providers, CSP, or the cloud service providers like your AWS, Azure, GCP, Alibaba, OSI, all such type of clouds, right? Azure, you can basically deploy these virtual images as well. In virtual images, they have a couple of series, like they have a VM 50, very basic. This is for lab only. Then they have a VM 100, VM 300, and VM 700. These are the VM models basically offered by the Palo Alto Firewall. But nowadays, If you don't want to go with these models, then you can just go with the CPU and RAM. Let me just show you here. Like in the VM series, if you will see, we have a VM700. It has a throughput of 16 Gbps. 16 Gbps is a very good throughput. Then threat prevention 8 Gbps. It has a new session per second 1,20,000. Dedicated CPU cores 2, 4, 8, and 16 CPU it will support. Dedicated memory 56 GB. Dedicated hard disk 60 GB. Then we have VM500, VM300, VM100, and VM200. Then VM50, which is a light version just for the lab. Okay. And this is how you can define the CPU and RAM basically. Then we do have a container native series firewalls, or the cloud native or container native or the CN series firewall, right? CN series provides visibility and security to containerized application workload, means the application workloads which we are managing through the Kubernetes clusters and all, right? And if you want to secure the traffic from these applications, you can deploy the CN series devices. Natively integrate into the Kubernetes clusters, provide layer 7 visibility, application level segmentation, DNS security, and advanced threat prevention. Protect traffic across trusted zone in public cloud and data center environment. Okay, so we can use the CN series box as well for the same. This is something I need to clean. So guys, any doubt with regards to the hardware appliance or the virtual appliance? Because see, you don't need to remember the each and every model, just remember the series. We have a 200 series, or just remember the latest one like 400, 1400, 3400, 5400, and 7 7500 series. Just remember that thing, that is sufficient for an interview. So CN series devices generally we will used for in the Kubernetes clusters. Okay. So if you have worked with the Kubernetes cluster, where what with the help of Kubernetes clusters, we can run our applications as a workloads. So the thing is, if we want to secure that the traffic for these applications, right? What we can deploy Palo Alto Firewall also as a workload there. So Nilesh, Palo Alto Firewall do supports the SD-WAN, even though your virtual Palo Alto device do support SD-WAN, but it's the native SD-WAN. Okay, you just need a license for that. But if you want the actual SD-WAN solution from Palo Alto, then you need to purchase the ION devices. ION devices, the dedicated SD-WAN devices. Okay. Now, before going into the single pass software, guys, let me try to cover one more very good topic. Then I will basically go for this next generation or single pass software and parallel processing hardware. I think but we just have a 30-minute left, right? So now let's discuss this next generation firewall versus legacy firewall, and after that I'll just wind my session. And on tomorrow class I will start with your SP3. So we will cover SP3 in 1 hour. Then basically I will start your packet flow. So let me just go into this PA feature. Let's try to understand this next generation firewall and legacy firewall, because in your interview they will ask what is next generation firewalls and what is legacy firewall. What is the difference between them? Let me just clean the things little bit. Okay. So let's take an example, guys. We are having this particular diagram. Ultimately, I'm going to use this. Okay. No. So, let's take an example. We have this particular diagram. So, guys, let's try to understand the legacy firewalls. Or what is legacy firewall? So, if you want to know about the legacy firewalls, so they are the firewalls who can control the traffic on the basis of layer 3 information and layer 4 information. Means they can basically only able to control means they can able to allow the traffic, or they can able to deny the traffic on the basis of layer 3 information and layer 4 information. And at layer 3, what we have three things: source IP, destination IP, and layer 3 protocol. At layer 4, what we have? Source port and destination port, right? Means according to your TCP model, TCP IP model, legacy firewall can only able to allow or deny the traffic on the basis of layer 3 and layer 4. But let's take an example. I am a hacker and I have created one malware. I have created one malware. Now, guys, this malware, let's suppose I have stored in one of the file. On this file, I have basically added this malicious code. I have added this particular malicious code into this particular file. Now, what will happen? Now, let's suppose if this particular file I want to send into this computer over the internet. On this PC, I am trying to send this particular file via the internet. Let's suppose this file hosted into this server. Now, what will happen? This particular malware comes as a layer 4 information or as a layer 3 information? Tell me, guys. Where exactly this particular malicious code available? This malicious code of that malware is available. It is available at layer 7. Because your legacy firewall cannot able to understand layer 7. This understanding is not available at your legacy firewalls. Now what they do now? Then how they can able to basically, how they can able to block this particular traffic? How this particular, let's suppose we have a firewall here, it's a legacy firewall. Now how this firewall can able to protect this PC from this malware? It is able to protect, guys. It is not able to, because it is not capable enough to read the layer 7 information. If it is not capable of doing this particular malware analysis, that is the main reason this particular firewall is known as a legacy firewall. That's why this firewall is a legacy firewall. Now, we have a firewall here. I am taking example of Cisco. So we have a Cisco ASA. On Cisco ASA, we have rewrite the ACLs on the basis of layer 2 to layer 4 information, right? And my ASA firewall, it will not able to protect me from any type of layer 7 attacks or any type of malwares. Now let's take an example. If somebody trying to launch a attack, or let's suppose somebody is trying to send some type of virus or some type of spyware or some type of somebody is trying to exploit some type of vulnerability. Now what do you have to do? Is your AS able to protect? No, it is not able to do that. So what you have to do now? Now you have to basically purchase one more box from Cisco, which is a IPS, intrusion prevention system. And when you will purchase the IPS, what you will get the layer 7 functionality, but you will get the protection from virus, spyware and vulnerabilities. Now let's take an example. Now you have a one more requirement. You need a you need to block the downloading of files. You need a file protection. You need a protection from malwares. You need a DLP protection. For that, if you want these protection, because these things also comes under the layer 7 only. File blocking, malwares, DLP, and the let me just write here. What I can write here, sandboxing. If somebody is not aware of the sandboxing is a technology which protects us on the real time basis from the unknown malwares or the unknown phishing domains or the newly created malwares whose signature is not available. Okay. So for that word, if you are a Cisco lover, then you have to purchase Cisco Advanced Malware Protection Box, AMP box, AMP. Now you have one more requirement. Now you want a URL filtering. Plus you want a SSL decryption. Then you have to purchase one more box from Cisco, which is WSA or ESA. That was the market we were having previously. It's a very legacy design. Now guys, think about the situation where when you receive a packet, you receive hit the firewall. Your firewall do layer 3 to layer 4, then your firewall forward this packet to IPS, then IPS will process, then your M will process, then your ESA or WSA will process, and after that only your packet reach till the destination. This is the destination. What will happen? Because these are the dedicated boxes. Now what do you have to do? These are the dedicated boxes. So you know, when because your packet is going into firewall, then IPS, then AMP, then WSA, it will add some extra delay. Yes or no? It will add some extra delay, right? Because firewall take time for the processing, then your IPS will take time for processing, then AMP will take the time for processing, and your WSA will take the time for processing, right? And because these are the individual boxes, right? Even though see IPS, AMP and WSA, they just needs to process the layer 7 content from your packet, but ultimately they also needs to extract the layer 2 to layer 4 information, right? Without extracting layer 2 to layer 4 information, are these devices able to do that? No. Ingress processing, they have to check the headers and all, right? These sanity checks each device needs to perform, right? Otherwise it cannot able to get the detail, it cannot able to provide us the best security. So like your layer 2 to layer 4 processing is repeating on all the devices? Yes or no? It is, right? So the thing is, if this is the case, then because of these particular multiple series of boxes we are having in our infrastructure, right? It used to add some extra delay on the packets. You needs to put lots of extra cost For purchasing these boxes, for maintaining these boxes, you have to manage the life cycle of these boxes, which includes the upgrade of the boxes, replacement of the boxes, right? You need a very good network engineers who can manage all these boxes. You need all the license into these boxes, right? So guys, that was the problem we will be having with regards to the legacy firewalls or the legacy designs. Now, what Palo Alto is doing, Palo Alto basically put all these features just in single box. PA firewall means all these features are available into the single box. Means now your Palo Alto firewall basically providing the protection on the basis of layer 3, layer 4 and layer 7 protection as well. And because Palo Alto have a support for layer 7 protection, because of that it has a couple of very cool feature like your antivirus protection, anti-spyware protection, vulnerability protection, app id. You can write the policies on the basis of applications. It has a features like file blocking. You can control the file. It has a file protection, I can say. It has a wildfire. Wildfire is a sandboxing technique. We have a DLP, data loss prevention feature. It will not give you the 100% DLP, but you will get the some extent of DLP as well. It has these particular dedicated features, and also it is having the DOS protection. It is having the zone protection. Even though DOS protection and zone protection you can put in the Palo ASA as well. Okay, but with the ASA, with the IPS, you will get the very good results. Okay, so your Palo Alto firewall having all these cool features. Then that is the main difference between your next generation firewall and legacy firewall. Your next generation firewall process the packet on the basis of layer 3, layer 4 and layer 7 information. Means it can allow the traffic, it can deny the traffic on the basis of layer 3, layer 4 and layer 7 information. But your legacy firewall only able to protect you by using the layer 3 and layer 4 information, and your legacy firewall, they are not capable of reading the layer 7 content. So they are not having features like antivirus protection, anti spyware protection, vulnerability protection, app id, file protection, wildfire, DLP, URL filtering. I forget to mention URL filtering here, right? URL filtering, these features is not available into these boxes. So now I hope you understood why we need to migrate our legacy infra with the next generation infra. You will understand that migration from this analogy, and why we are using this next generation firewall instead of these legacy firewall, because of these particular features. Okay, now as I mentioned, we have a couple of legacy firewalls like your Cisco ASA, Juniper SRX, Sophos, CyberRoam, SonicWall, ForcePoint, and there's a couple of we have a firewall from Dell, HP as well, right? These firewalls comes under the legacy network, and they can only control the traffic on the basis of layer 3 and layer 4 information. And your next generation firewalls, we have a Palo Alto Networks, and Palo Alto Network also the market leader. Then we have Fortinet, a FortiGate firewall, which is a second market leader. Then we have a Checkpoint. Then we have a Cisco FTD and FMC. These are the four firewalls comes under the next generation categories. And these next generation categories firewalls, they have a features like your URL filtering, antivirus protection, anti-spyware protection, vulnerability protection, your app ID, right? These are the cool features available on your next generation firewalls. But let me tell you guys one more thing. See, Cisco ASA is a very stable box, and I really love this particular device. It is a very stable device, and if you are having next generation firewall, then I highly recommend you can use ASA firewall for the IPsec tunnels and all. You will get very good throughput, and you can just put this box into your rack and forget for 10 years. It will not, it will give you very good eye throughput and all till 10 years. So it's very nice legacy firewalls actually. Okay, so guys, this is the main difference between next generation firewalls and legacy firewalls. Okay, now, so this is what I'm having. Let me just see if I have anything else to cover. So these are the layer 7 features like app ID, URL filtering, virus protection, spyware protection, vulnerability, data protection, file protection, wildfire sandboxing, which are available just in your next generation firewalls, and these features is not available into your legacy firewall. So we will basically, that is the main reason of that is the main reason people are migrating towards the next generation devices nowadays. So like packet inspection into your next generation firewalls till layer 7, and packet inspection in your legacy firewall till layer 4 only. Okay, so this is what which I used to cover with regards to legacy networks and all. Let me just cover guys one more topic. Okay, if you will get it, that is okay. If you will not get it, that is also okay. I'm completely fine with that. But before that, let me just, let me just clean this little bit. That's the problem with this whiteboard. Sometimes it's become very slow actually. It is acting very funky today. Not able to cleaning properly. Okay. Okay. Now, so guys, what I just wanted to tell you, I'm just telling you some information regarding the Palo Alto firewall processing actually. So we have this PC1 having IP address 10.1.1.100. Now I will go with the proper. This is my Palo Alto firewall. This interface is Ethernet 1 by 2. It's a part of inside. This is in my Ethernet 1 by 3. Let's suppose it's a part of DMZ zone. And here I have one of the server. Server 1 having IP address 10.2.2.101 running the service on TCP port 80. Okay. This is the very simple I'm having. Simple setup. Now guys, tell me one thing. Because why I'm I'm trying to explain this part here, so you at least get the idea, because this particular thing will help you throughout the session. So guys, let's suppose this server URL is dmz01.lab.local. Now on this PC I have opened the web browser and I have typed dmz1.lab.local. What is the first thing this particular PC will do? It will basically send the DNS request. It will send the DNS request towards your local DNS server, and sending DNS request, it will basically get the DNS response. It will get the IP address, which is 10.2.2.101 for this website. And after that, the second thing, what it will do, it will go through with the TCP three-way handshake. And the third thing, what it will do, it will basically now, once TCP three-way handshake will complete, because it's a normal web server, right? So now it will exchange the, or I can go in this way. And after that, what it will exchange, it will do the normal HTTP traffic, right? It will exchange the HTTP or web traffic. This is the flow, right? Now let me just start from TCP three-way handshake. It will send the very first packet, TCP send request. Send received by the firewall, right? Now what I wanted to explain you here, now let's try to understand how firewall going to do the TCP send request processing. TCP send processing. It's a very first packet processing. So when Palo Alto start the processing for TCP send request, what it will do, the very first task it will do, it will basically put this particular packet into the ingress stage. Then it will perform the flow lookup. Flow lookup means it will do the lookup into the session table, right? Because Palo Alto is a session, is a stateful firewall, right? Because you know, guys, is Palo Alto Firewall to see any type of session into the session table for this request? It will not. Why? Because it's a very first packet, right? Means firewall is not having any session into the session table. If it is not having any session into the session table, then what it will do? It will basically send this packet into the silo path. Silo path is also known as, guys, session setup stage. Then it will, once it will complete the silo path, it will go through with the routing lookup, net policy lookup, it will go through with the security policy evaluation. And let's take an example, my firewall is allowing this traffic, so now it will go into the fast path. Fast path is also known as layer 2 to layer 4 processing. Then it will basically go into the forwarding stage. Okay, this is how your send request is processed by the Palo Alto firewall. Now the second packet, what we will receive, TCP SYN plus ACK. Now let me write down how firewall going to do the processing for TCP SYN plus ACK. This is the second packet, right? TCP SYN plus acknowledgement. So what it will do, it will start the TCP SYN plus ACK processing. What it will do, it will put this ACK packet into the ingress stage. Then flow lookup. Guys, tell me one thing. Is this time my firewall able to found any type of session into the session table? Yes or no? It will able to found the session because it has created when he has received the SYN request. So flow lookup, because session will be there when he has performed the flow lookup or the session lookup into the session table, session will be there, so it will bypass the slow path and your packet directly jump into the fast path. Then it will go into the forwarding stage. And after that, we will see, it will send the third request. TCP acknowledgement. Now let's try to understand how firewall going to do the TCP ACK processing. So I'm just putting this detail here. Let me use some different color. TCP ACK processing. What it will do, it will put this packet into the ingress stage, because each and every packet will go through with the ingress stage, guys. Every packet will go through with the flow lookup. Then for this packet also, it will bypass the slow path. So what it will do, it will directly jump into the first path and then forwarding stage. Okay, now, and guys, your processing will start always from the ingress stage, because this is the first stage. And there are the packet processing stages on Palo Alto Firewall, and it's a very first stage. Okay, just remember. I'll show you this thing. That's not a problem. I just wanted to explain you this, how the TCP transactions is happening through the firewall. Okay, now till here your TCP connection is established. Now the packet which we will receive, which is HTTP GET request. It is received by the firewall. Now how firewall going to do the processing for HTTP GET request? So I'm just writing here HTTP GET processing. What it will do? Ingress stage, flow lookup, then fast path. Now, because Palo Alto is a next generation firewalls, right? And it has a support for app ID, URL filtering, antivirus protection, anti-spyware protection, vulnerability protection, data protection, right? Wildfire, file file blocking, file protection, right? Means now, because see, TCP SYN plus ACK and ACK. But these three packets, they don't have any type of layer 7 data. Just remember, they are the empty packet. They are not having anything at layer 7. But your HTTP GET request, it has a layer 7 data. So your packet is starting from this HTTP GET. It will go through with the app identification, which is app ID. This packet go through with the content identification. Content ID means content ID includes your antivirus protection, anti-spyware protection, vulnerability protection, file blocking, DLP, right? Your wildfire, URL filtering, everything comes under the content ID only. Okay. Then the forwarding. That's how your HTTP get packet processed. Then we will get the reply. HTTP response. Now let's try to understand how this HTTP response is going to process by the firewall. So for that, I needed little bit space here. HTTP response processing. Because here you also need to understand one thing. The first stage, ingress stage. Second one is flow lookup. Flow will be there, right? So fast path. Then fast path, what is the stage it will go here? What you will think, guys? According to you, what stage it will go? HTTP response have the layers of information. It will go through the content ID. It will bypass the app ID and it will go into the forwarding stage. Why it is bypassing this app ID? Because when your HTTP get go into the Palo Alto firewall, when Palo Alto start processing this HTTP get request, when this packet reached into the app ID, your application is identified. Your application is identified as a web browsing. Then there is no sense to send all the request into app ID again and again. It will not send. What it will bypass the app ID, it will just send the packet into the content ID. Now you may ask one thing. Let's take an example. My application is changed. Let's suppose, let's suppose, let's suppose, let's take an example of Facebook. So let's say whenever we are accessing normal Facebook page, Palo Alto identify this application as a Facebook base. But let's say suddenly on the Facebook we are start using the Facebook chat. Then Palo Alto identify this application as a Facebook chat. Then how it will detect this Facebook chat? Because in content ID, guys, it will try to do one more task, which is application shift. Okay, so that's how, guys, your packet processing happens on the Palo Alto firewall. Just remember these stages. Why these stages are important? Because it's a base. This is the base of your entire training. If you know this particular processing, or if you know the flow, you can able to troubleshoot the issues, because you know how my pan OS reacting on different packets when my system is communicating. Okay, now let me show you one more diagram and after that we will bind up. Where is that one? Let me see if I have anything here. No, I don't have. Go back. I just wanted to show you the packet flow diagram. That's it. And I will show you one more diagram and after that we will bind this session. So I need around 5-6 minutes more. Or the better, we can go here. Palo Alto packet flow. This picture is not clear. Guys, this picture is clear. Are you able to see this picture properly, or it's not visible? It will not. Okay, this is the high resolution one. Oh, this is the one. This is good, right? So as I have mentioned, why I have introduced Ingress, because see, when we receive a packet on your Palo Alto firewall, on any interface, what it will go through with the ingress stage. And ingress stage, it will basically do all these checks. What are these checks? We are going to discuss. Then it will go through with the flow lookup. Then your silo path. See, session match pound. If yes, then fast path. If no, then silo path. In silo path, we are doing routing lookup, net policy lookup, and security policy evaluation. And everything is good, it will create the session, it will install the session into your session table. Then it will go through with the first path, which is layer 2 to layer 4 processing. SSL proxy I have not touched yet. Then your app ID, appling identification, there is a hell lot of checks on app ID. Then your content inspection, content ID. In content ID, you can see here, it will detect the application changed. If application is changing, it will detect the application shift as well, right? And in content type, it will perform the protocol decoding, parsing, content matching, tunneling application and all, right? And after, at the last, it will go through with the forwarding stage or either the egress stage. So these are the 7 stages I just wanted to explain you guys. And remember one more thing, before you are coming to tomorrow class, read this particular architecture. Read this particular document, packet, Palo Alto packet will sequence in Panos properly. Otherwise, you will not understand the things for tomorrow. Read through it, because I'm going to explain each and every steps. But see, this document they have released. Let me reset. In 2018, which means it's around 6 years old diagram, old document, right? And it is only valid for PanOS 7 and 6 operating system. But right now we are at which version? We are at 11, right? They have done lots of changes actually. So because I will basically cover these changes as well on the latest packet flow diagram. So that's why if you will read through with this diagram, you will get the idea. Okay. Just read through it and come into your tomorrow in the tomorrow session. So guys, this is what which I wanted to cover with regards to your today's class.